Hey everybody, Dr. Nelson here. This is a video about graphing quadratic functions in Vertex Form. So the first page I want you to follow along with me, and then you have a chance to try a problem on your own, and at the end you can see how you did. Alright, so here we have the function f of x equals 1/4 times x minus 1 squared plus 4. And this is already written in Vertex Form. And remember, this is the format for Vertex Form. And what you need to know about this, to graph this function quickly, is the vertex is the location of h and then k. So hk gives us the point of the vertex. So for here, we have an h value of 1. So we're going to say h is 1. And our k value is 4. So our vertex is located at 1 and 4. So if we plot that 1 and 4, right there is going to be the vertex. Now, because our a value is negative, we know that this is going to be a maximum value. So it's going to be a downward graph. Okay. Now, the last thing you need to know, actually a couple more things, is that this line right here is also the line of symmetry. Okay. So x equals 1 is the line of symmetry. So now what we need to do is we need to find a value to plug in for x, all right, to get a y value. We want to use a number that's on the graph that's pretty easy to use. So let's say, for example, if I used, say, x is 3, okay? When I plug a 3 into the function, 3 minus 1 is 2, and then 2 squared is 4, and then negative 1/4 times 4 is negative 1, and negative 1 plus 4 is 3. So when x is 3, y is also 3. So I can go over here to 3, and then 1, 2, 3. And because I know for a fact that this point is 2 away from the line of symmetry, I can put another point 2 away on the other side, like that. Alright, let's go with another point. How about if I said if x is, how about 5? So if I plug in a 5 for x, 5 take away 1 is 4. 4 squared is 16. And 16 times negative 1/4 is negative 4. Negative 4 and positive 4 is 0. So when x is 5, I know y is going to be 0. So 5 and 0 is going to be right here. And this point is 1, 2, 3, 4 away from the line of symmetry. So I'm going to go 4 more this way. 1, 2, 3, and 4. And here you can kind of see the outline of our graph. If you want, you can do maybe one more point to make it even more accurate, but really there it is. So again, to summarize, if you have a function in vertex form, if you know the h and k values, that's the coordinate of the vertex, and then once you know that, you also know the line of the axis of symmetry. Alright, so now that you understand this, why don't you pause the video and try the your turn problem now, and when you're done, hit play. You can see how you did. Alright, good luck. Alright, welcome back. Let's say I do this practice problem. So here we have the function f of x equals x plus 2 squared minus 1. So I know that the x value for this one is going to be a negative 2, and that the k value is going to be negative 1. So negative 2, negative 1 is going to be right here. Alright, and really there's a 1 in front of these parentheses. So I know that the a value is going to be a positive, right? So it's going to be, this is going to be a minimum. So now we need to plug in a value for x. So let's use, say, the number 2. Or actually, let's use the number 0. That'd be even better. So 0 plus 2 is 2. 2 squared is 4. And 4 take away 1 is 3. So when x is 0, y is 3. So here's 0 and y is 3. And we also know that this negative 2 is also the axis of symmetry. And that's 2 away from our point, right? So I'm going to go 2 on the other side. And there's a couple points. So we know that our vertex is at negative 2 and negative 1. And our axis of symmetry is at negative 2. So finally, let's do one more point. How about if I said if x is, say, how about 3? Okay. If x is 3, 3 plus 2 is 5. 5 squared is 25. Take away 1 is 24. So 3 and 24 is not the best point to use on this graph because it only goes up to 8, right? So let's maybe try, say, a negative. How about a negative 1? So negative 1 is going to be our x value. Negative 1 plus 2 is 1. 1 squared is 1. And 1 take away 1 is 0. So negative 1, 0, that's going to be 1 point. And that's 1 unit away from the axis of symmetry. So I'm going to put another point right here. But let's use, say, how about positive 1 for x? So if I put a positive 1 in here, 1 plus 2 is 3. 3 squared is 9. And 9 take away 1 is 8. That's better. So if x is 1, y is 8. And this point is 1, 2, 3 away from the axis of symmetry. So let's go 3 over this way. 1, 2, and 3. And now we can really see our parabola, right? And here it is. And of course, we want to add arrows to the top because it keeps on going. And there's your function. All right, how'd you do?